In the next little bit, it is going to be important to determine if vectors are in the same plane. To find out if three given vectors will lie in the same plane, there's a simple test we can do. So we're going to consider three vectors, vector u, v, and w. If u dot v cross w equals 0, then the vectors are coplanar, meaning they lie in the same plane. And if u dot v cross w does not equal 0, so it equals anything other than 0, the vectors are not coplanar. Now I do want to mention a couple of things. So the first thing, that the order doesn't matter. So you could put the u, the v, and the w in any order that you want. But when I look at this formula, there is something very important here. You must complete the cross product first. So you have to do the cross product of two vectors before you can do the dot product. We know that when we do the dot product, we get a scalar result, and then we won't be able to do a cross product with a scalar and a vector. So the cross product must be done before you do the dot product. And for those of you that like some good explanations, I'm just going to explain this a little bit further here. We are going to do the cross product, so I'll just say v cross w. Now we know that when we do the cross product, what we're getting is we're getting a vector that is perpendicular to these. If I now take that perpendicular vector and I dot it with the third vector, in this case u, and it equals 0, what that is telling me is that that perpendicular vector from when I did the cross product is perpendicular to that third vector, meaning all three of our original vectors lie in the same plane. And one final thing, let's consider vectors A and vectors B. I'm going to tell you that vector B is a scalar multiple of vector A. So vector B is equal to -5/3 times vector A. What we automatically know is that these two vectors are collinear. And if two vectors are collinear, then that means that they're also coplanar. So now if I were to introduce a third vector, vector C is equal to 2 times vector A plus 3 times vector B. So vector C is a linear combination of vector A and B. So since this is just a linear combination, I know that these are also coplanar. And if I were to do that test from earlier, so C dot A cross B or any combination of those, that would also equal 0. So to add on to this, because we have vector C being a linear combination of vector A and vector B, what we are able to say is that vector A, B, and C are linearly dependent. And then just because I want to clarify everything for everybody, if we have vectors that are not linearly dependent, vectors that are linearly independent, we wouldn't be able to write them as linear combinations of each other.